So we're going to look at a warm-up question from yesterday's, that process of completing the square. What's the first step? Okay. If we divide everything by 3, we end up with x squared minus 6x minus 2 equals 0. Then what do we do? Add the 2 over, okay, get rid of that constant term. We are going to leave a little space there, right, because we're going to complete the square. How do we find that missing number? Okay, we take b divided by 2 and square it. In this case, b is negative 6 divided by 2 gets us negative 3, and if we square negative 3, we get 9. So 9 is the missing number, the perfect number that would make that a perfect square trinomial. So we're going to add 9, but we have to add it to both sides, right? On the left side, we've now created a perfect square trinomial. Factors into what? Okay. And then on the left side, 11. And then we square root both sides. Remembering your plus and minus signs. And then we're back to saying x minus 3 equals positive and negative square root of 11. And then our last step, add that 3 over. Okay. How did we do on the warm-up? Good? Okay. I do want to look at question 50 from your homework last night. We talked a little bit yesterday, I think in this hour, about what do we do when there's an a term, right? When there's a number in front of the x squared and you're trying to complete the square to put it in vertex form. There are 2 ways to look at this, and I am going to show you both ways. There's places in each method where students typically make mistakes, so there's not really one method that's better than the other. You can certainly use whichever one seems to make more sense to you. Just watch those spots where I'm going to point out this is a common place for a mistake. Okay? So, first thing, let's say we're going to divide that 2 out. We end up with y divided by 2 equals x squared minus 3x minus 1/2. Okay? What would our next step have to be? Add the 1/2 over. All right. Then we need to complete the square, right? We need to find that missing term. So what should be here? We take negative 3 divided by 2 squared. When you have a fraction and you're squaring it, just square both numerator and denominator. So we end up with 9/4. So I'm going to add a 9/4 to both sides. All right. Now, on the left-hand side, I have 2 constants. I have a 1/2 and I have a 9/4. I want to put those together. I need a common denominator. 1/2 would be the same as 2/4 plus 9/4. We get 11/4. Okay. On this side, we factor that perfect square trinomial back into what? X minus 3/2. Remember, this number is always going to match this, right? It's the number you had before you squared it. Then we are going to bring the 11/4 back over. And then our very last step is that we have to multiply 2 to the other side, right? We're actually multiplying both sides by 2 to get it to drop out on the left. So when you multiply both sides by 2, the left turns into just a plain y. On the right-hand side, both of these parts have to get multiplied by 2. So we're going to take 2 and multiply it to the factored piece here. We're also going to take 2 and multiply it to the negative 11/4. When you multiply negative 11/4 by 2, what does it reduce to? negative 11 halves. We can reduce the 2 and 4. Okay. Is that in vertex form? Yes. We have a 2 in front. That's our A value. Our H value would be this 3 halves. And our K value would be the negative 11 halves. Okay? Now, the other method, if we have, what did we have? Y equals, what was it, 2x squared minus 6x minus 1? Some people, knowing that that 2 is going to be in front, right? That's going to be that A value. They're going to leave it over on this side, on the right-hand side. So I'm going to add the 1 to the other side. I'm going to divide out the 2 because I have to do that in order to complete the square. But I'm going to leave it on that side. Okay? Instead of dividing it to the other side, I'm just going to factor it out. Is that equivalent? Okay. So it's going to sit there in front because that's where my A is going to end up in my final vertex form. I still have to complete the square, and notice that what I'm going to add in where the hole is inside the parentheses. We would go about figuring out that missing term the same way we did earlier. Take half of negative 3 and square it. So we are still going to put a 9/4 here. This is where students make the mistake. Because what I really put on this side, even though you see a 9/4, it is inside the parentheses, which means this 2 out front has to be applied to that. So I didn't really add 9/4, I really added 9 halves. 9/4 times 2. So if I added 9 halves to this side, I have to add 9 halves to the other side. Now when I combine like terms, I have 1 plus 9 halves. The 1 would be 2 halves. So 2 halves plus 9 halves gets me that 11 halves. There's a 2 out front. The trinomial piece factors back down. All right, and then we can subtract the 11 halves back over. So we're going to end up with the same answer. It's just a different, slightly different way of working through it. To me, that seems a little easier, the second method. But again, that common mistake right here. Students put 9/4 on this side, and they want to write 9/4 on this side, forgetting that the 9/4 is getting multiplied by the 2. So you do have to make that adjustment if you're using that method. Okay? All right, go ahead and pile up your homework, and I will grab it. Get your notes out for section 4.7, and I'll give you a minute to write down the objectives. So we've been solving quadratic equations, and we have 4 basic methods that we use. We have a 5th one that's graphing, but we don't use it very often. So of the key ones that we're going to be testing on, factoring was the one we looked at earlier. Then we moved to simply being able to square root both sides. Okay, that was when we didn't have a b term. Okay, then we went to completing the square in order to create one that we could put in the format where we could square root both sides. And our last one that we're going to look at today is the quadratic formula. Okay, you guys learned the quadratic formula a few years ago? Yes? All right, so give me 1 second here. Notice that in your quadratic formula, you have to have it equal to 0. Yes? Right over here? We have to have it equal to 0 in order to identify A, B, and C. If it's not equal to 0, you need to do some rearranging. All right. All right, do you guys remember that from? You guys remember that? Yes? All right, I'm not going to make you sing. However, keep that in mind if you're having trouble remembering the quadratic formula. There are songs to help you remember it. So for our first example, do we need to do any rearranging? Yes. What do we have to do? Yes, we have to move that 4 over. So 2x squared minus an x minus 4 now equals 0. Can you identify a, b, and c? What would my a value be? A is 2. B is? Good. -1. C? All right, -4. So we are going to dump in. The opposite of b would be +1. Plus and minus a square root. Now be careful right here. Our b term is getting squared. If you're going to type this in your calculator, you have to put that in parentheses so it squares the negative with the 1. It should come out as a positive value there. Then we're subtracting 4 times our a term times our c term. And then the whole thing, that's another place that it's a common mistake. Students divide the square root part, but not the whole equation. All of it is divided by 2 times a. So once we've gotten our one side equal to 0, we identify a, b, and c, we dump them into our equation. Then we start simplifying it. We've got 1 plus minus a big square root. Denominator becomes just a 4, 2 times 2. And now let's clean up what we had in that square root. What's -1 if we square it? We get a 1. Then it says we're subtracting 4 times 2 times -4. Well, 4 times 2 is 8. 8 times -4 is -32. If we're subtracting a -32, we are really adding 32. So we end up with x equaling 1 plus minus the square root of 33, all divided by a 4. Can we break down the square root of 33? Is there a perfect square factor in there? If there was, I'd be expecting you to do that. Okay. All right, let's look at our next one here. X squared plus 6x plus 9 equals 0. Dumping it into our quadratic formula. We want the opposite of 6, so -6, plus minus the square root, b squared, so 6 squared, minus 4, a is 1, c is 9. On the bottom we have 2 times a, so 2 times 1. When we go to simplify this one, denominator is now just a plain 2, and inside the square root, what happens? 6 squared is 36, and we're subtracting 36. So we really have the square root of 0. What's the square root of 0? 0. If we add and subtract 0, does it do anything? So really this just simplifies down to being -6 divided by 2, which would be a -3. All right, I'm going to pause the recording. I want you guys to try the next 2. All right, so looking at these last 2 examples of our quadratic formula, we're going to bring the -4 to the other side first. We're going to dump them into our quadratic equation here. So opposite of b, plus minus square root, b squared, minus 4 times a times c, all over 2 times a. We end up with -4 plus minus what? We get 16 minus 16. So it's another one where we're getting a square root of 0. That's going to drop out. We end up with -4 just being divided by 2. So we get a -2 for an answer. Okay. On our last one here, we've got x equaling the opposite of b plus minus square root b squared minus 4 times a times c all over 2 times a. What do we end up with inside our square root? We end up with 16 plus 12, right? Subtracting a negative 12. We're really adding 12, which makes it a 28. Can we reduce the square root of 28? All right, think of it as 4 times 7. So the 4 turns into 2. All right, so we have x equaling negative 4 plus minus 2 root 7 all over 2. What you have to be careful of is that 2 in the denominator applies to the whole numerator. That means the negative 4 is going to get divided by 2, and the 2 root 7 is going to get divided by 2. So we should end up with x equaling negative 2 plus or minus what? We had 2 root 7. If we divide out the 2, we get 1 root 7. Okay. I want you to look back at the 4 examples we did. 2 of them gave us just a single solution. Yes? The second and third examples. What happened in the question that led us to just having one answer? We ended up with square rooting a 0. Okay? There's a name for the part that's under the square root, that b squared minus 4ac. It's called the discriminant. That discriminant, that piece underneath our square root, is going to tell us, before we even finish the question, how many solutions we should get. If it comes out 0, we just got one solution. The other 2 examples, we ended up with some kind of positive number inside our square root, which led us to getting 2 answers. Okay? Do you know what would happen if it was a negative inside the square root?
It wouldn't work.
Why wouldn't it work? You can't square root a negative if you're limited to real numbers, right? Which right now we are. We're just looking at real solutions. So if I was looking at the square root of, say, a negative 13, I'd say there's no solution to that. However, as we go on in our next few days of notes, we're going to start looking at what happens with those negative square roots, or negative inside a square root. Skip over the word problem. We'll hit that one tomorrow. Go to this chart. The chart, at the top I wrote b squared minus 4ac. That is what we call the discriminant. So if I say evaluate the discriminant to determine how many solutions you should expect. If that discriminant comes out positive, something bigger than 0, we're going to get 2 solutions, which means we're going to have places, 2 different spots where our parabola will hit the x-axis. Okay? If it comes out as exactly 0, our parabola is only going to touch the x-axis in one spot, which makes it the vertex. And if it comes out as a negative, something less than 0, right now we're saying no real solutions, but eventually we're going to work and figure out that we can have some imaginary ones. But if they're imaginary, they're not going to show up on your graph. So when you look at your graphs over here, you'll notice we didn't touch the x-axis at all. Okay? So we are going to look a little bit more at the discriminant. We're going to do that word problem. And then, again, the next set of notes, we will get started on 4.8. So you guys are working through the first assignment here. Day 1, 11 through 22, actually, I would expect to see some work shown here, similar to what we have in our notes today.